Hello, my name is Ian, and this is my ME210 video for Impulse and Momentum. And in this problem, it is a mouse on a wheel and its angular momentum. And in this problem, Ian is conducting an experiment on a mouse to determine how fast it can make a wheel spin. Typical mice weigh 60 grams and can run at a speed of 1.3 meters per second. An average exercise wheel has a moment of inertia about its center, which is 0.25 kilograms times meters squared. The radius of the wheel is 15 centimeters, and the mouse is treated as the point of mass. How fast should the wheel be rotating? So my givens are that the mouse is 60 grams, the velocity is 1.3 meters per second, and the inertia is 0.25 kilograms times meters per second or squared. The radius of the wheel is 15 centimeters, and the angular velocity is radians per second. My assumption is that the mouse does not slip. There's no drag on the mouse. The wheel is a rigid structure, and gravity is equal to 9.8 meters per second squared. And lastly, my last given is that the mouse is a point of mass, which means it's rotating around that. In this diagram, it is a standard XY axis with the radius of the wheel being shown, the angular velocity going clockwise, and the velocity going to the positive X direction. For my solutions, the equations that I used were that angular momentum, which is HF, H final, is equal to H initial, HI. This can further be broken down into H wheel plus H mouse, which is equal to 0, because we know that the conservation of energy is going to be the same, meaning also that the wheel and the mouse are in tandem together. This can be further broken down into H wheel equals negative inertia times angular velocity, and H mouse, which is negative because it's into the paper, using our right hand rule. H mouse is equal to radius times mass times velocity, and it's positive because it's coming out of the paper. This can finally be further broken down or equal to negative inertia times angular velocity plus radius times mass times velocity, which is equal to 0. And to find angular velocity is equal to radius times mass times velocity over inertia. And the final answer comes out to 0.468 radians per second. Once we've converted the centimeters to meters and the grams to kilograms, canceling all those out, we get, again, 0.468 radians per second. And finally, some key takeaways. Number one, that the conversion from centimeters to meters and grams to kilograms, knowing and using the conservation of angular momentum, knowing that it equals 0, using inertia and knowing when it is negative and positive, in or out of the paper, using our right hand rule. Thank you so much for watching.